Hello friends, myself Sumit Jain, Assistant Professor in CSE AIML department. So today we are going to understand what is data structure. And before understanding what is data structure, first we will try to understand what is data. So according to the dictionary definition, the quantities, characters or symbols on which operations are performed by a computer which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical or mechanical recording media. So according to the example C equals to A plus B, this A and B are my data. Now when data becomes information, so suppose I have some data like TERPSAJ space SIC space EMAN Iman space YM. Now if I try to get the meaning of this data, I am unable to get the meaning, and it is also difficult in reading. But if I apply some operation on this data, like I reverse this data, now this data becomes information. After performing reverse operation, you can see this becomes my name is Jaspreet. It is easily readable and also understandable. So we can conclude if data is arranged in a systematic way, then it gets a structure and also it becomes meaningful. Now we can say this meaningful or processed data is called information. And after understanding this example, it's not difficult to understand that the data needs to be managed in such a way so that it can produce some meaningful information. And to provide an appropriate way to structure the data, we need to know about data structure. So firstly, we will try to define what is data structure. So this is a basic definition. A computer program is a collection of instructions to perform a specific task, and for this a computer program may need to store data, retrieve the data, and after that perform the computation on those data. So whenever we are writing any program, firstly our program will take some data as the input that will be stored into the memory. After that we will retrieve that data from the memory, and then we will perform some computations on the data. So in the both three steps, input, retrieving and performing operations, we are using the data which is stored somewhere in the memory. The memory we are using to store the data is also a part of data structure. Here we are using the variable I to store the value 10, and the type of that variable is int, right? So we can say I is an integer variable. So this int is a data type and it is also called data structure. So a data structure is a named location that can be used to store and organize the data, and an algorithm is a set of steps to solve a particular problem. So data structure provides us the way for the storage of data, and algorithm is a set of steps to solve a particular problem. And when I will combine these two into together, data structure plus algorithm, we are able to write the efficient and optimized computer programs. So data structure is about rendering data elements in terms of some relationships for better organization and storage. For example, we have some data which has players name like Virat, age 26. Here Virat is of string data type and 26 is an integer data type. So with the help of this example, I am trying to say data structure says that if we are trying to store the data by using any data structure, we have to store that data in a way that we can access that data in efficient way, and also if some relationship already exists in the data, that relationship should be managed, that relationship should be retained, and we can organize this data as a record like player record, which will have both player's name and age in it. And now we can collect and store players records in a file or database as a data structure. For example, Dhoni 30, Gambhir 31 and Sehwag 31. Now we are defining the data structure now. Data structure is a way of collecting and organizing data in such a way that we can perform operations on this data in an efficient way. In other words, we can say it is used to implement an ADT. ADT means abstract data type. So for example, in order to implement stack ADT, we can use array data structure or linked list data structure. So here I am trying to say data structure are used to implement ADT, like stack ADT, queue ADT, tree ADT, graph ADT. So now we can conclude ADT tells us what is to be done, and the data structure tells us how to do it. What is a data type? So here are two important things about data types. First one is define a certain domain of values. In this step, we are defining the set of values which comes under this particular type of category, and in the second step we are defining the operations which are allowed on these data which we have defined in the step 1. If I talk about the example of this, int is also a type. So according to the step number 1 domain of values, it takes only the integer values. And if I talk about the operations, addition, subtraction, multiplication, bitwise operations we can perform. If I take the another example, float is also a type which takes only the floating point values. And if I talk about the operation, addition, subtraction, multiplication and division are the operations. Here the important point to note is that bitwise and modulus operations are not allowed. So when the type of data change from integer to float, these two operations are unable to perform. Why so? Because on the float values, bitwise and modulus operation cannot be applied. So with the help of this example, you can understand that data type is not just defining the type of values, it is also defining the what type of operations we can perform on this particular type of data. Now the next term comes user defined data types. So in contrast to primitive data types, there is a concept of user defined data types, and the operations and values of user defined data types are not specified in the language itself but is specified by the user. So for example, structure, union and enumeration are the user defined data types, and by using structure we are defining our O1 type by combining other data types. If I talk about the abstract data types, ADTs are like user defined data types which defines operations on values using functions without specifying what is there inside the function and how the operations are performed. So here is the major difference between data types and abstract data types. In data types, we define the type of values and what operations we can perform on those values, and the operations we are defining are clearly explanatory. We all know how addition, subtraction, multiplication and division are performed, but in the case of ADTs, operations are defined in the form of functions and without specifying what is there inside the function, right? So how that operation will be performed, we are not defining in the case of ADTs. If I talk about the example, stack is the ADT, and a stack consists of elements of same type arranged in a sequential order. And if I talk about the operation, all the operations of stacks are defined in the form of functions. You can see initialize, push, pop, is empty, is full, these all are the functions. Here initialize function, which we are calling operation, is saying that it is used to initializing it to be empty. Push is used to insert an element into the stack. Pop is used to delete an element from the stack. Is empty is used to check if stack is empty, and is full is used to check if stack is full. So if I want to conclude the abstract data types, we can say think of ADT as a black box which hides the inner structure and design of the data type from the user. So there are multiple ways to implement an ADT. If I talk about the example, a stack ADT can be implemented using array, or we can say linked list. So here we can conclude why ADT, why we are using the ADTs. So the program which uses data structure is called a client program, and it has access to the ADT, which we are saying interface. And the program which implements the data structure is known as the implementation. So if I talk about the advantage, let's say if someone wants to use the stack in the program, then he can simply use push and pop operation without knowing its implementation. And also if in future the implementation of stack is changed from array to linked list, then the client program will not affect. The client program will work in the same way without being affected. So here the conclusion is that if we are implementing the stack using array, and in the future if we are changing the implementation of the stack from array to linked list, the client program will not affect. It will work without being affected. So finally we can say ADT provides abstraction. So I hope you get the information about what is data structure. The next part of this lecture will cover in the next session. Thank you.